Okay, so in this question we have an Atwood machine that is set up where instead of both sides being hanging over the pulley, one side is a mass that is sitting on a level surface. And so we often refer to these as Fletcher trolley questions because you now have friction set up, so it's more like mass 2 that is pulling and making M1, making mass 1 move. So here you see the setup in your picture. Mass 1 is 5 kilograms that I have labeled, and mass 2 is 12 kilograms that's pulling down on the rope. They've given you a coefficient of friction, so you know there's an FF, and they want to work out what's the acceleration and what's the tension. So you see some of the forces labeled, and I'm going to fill them all in. So you've got FG2 coming down here, and you've got FG1 pushing down into the table. As you know, if you've got it sitting on a surface, if you've got gravity down, then you have a normal force pushing back, so you have Fn. So now mass 1 is obviously going to move to the right, so that means there's a friction backwards, and FF is going to be backwards. Now what makes this different than other questions is there's no FA, and the reason there's no FA is because you're not reaching with your hand and pulling on this rope or pushing on the block. The FG2 is the force that is going to be pulling this rope downward, right? So this is really going to substitute for the FA in your question. So what we're going to do though is we're going to work out, and we're still going to write an F net formula for all the forces that are working on this pulley right here. Okay, all the forces that are on the rope. So if I write a F net formula, my F net formula is going to be, well, what's pulling on the rope? FG2 is definitely pulling on the rope. So we have an FG2 trying to make the pulley turn. FG1 we're going to need, but that is not pulling on this pulley. It's not making the rope stretch. And Fn is not making the rope stretch, so they are not going to be included in my Fnet formula. But FF is definitely pulling on this rope backwards. So the only forces for my Fnet in these scenarios is FG2 and FF. So let's put in some numbers here before I go plugging those in. Let's work each of these out separately. Alright, so I want to keep most of the picture on here though. So FG2, this one here is mass 2 times gravity. So this is 12 kilograms times 9.81 meters per second squared. So that 12 times 9.81 comes out to 117.72 newtons. And I'll figure out the direction in a second. I just want to work all these out. So Fg1 is mass 1 times gravity. So it is 5 kilograms times 9.81 meters per second squared. So that's 49.05 newtons downward. Well, if we know that that's 49.05 down, then we know that Fn is 49.05 up. Well, if we know that Fn is 49.05 up, then we can get the frictional force, because it's mu times Fn. So the frictional force is 0.15 times that 49.05. So my frictional force is 7.3575. So I have a frictional force, and I have an Fg2. I can now plug those two things I just underlined into this formula. if I'm ready to think about direction. So FF over here, this force right here, is trying to make the pulley go in a counterclockwise direction. So FF is going to be a negative when I plug that in. FG2 is trying to make the pulley go downward in a clockwise direction, so FG2 is going to be positive. So I'm going to plug those two numbers in with the positives and negatives. My FG2 is a positive 117.72, and my FF is a negative 7.3575. So that net force comes out to 110.3625 newtons. I'm carrying way more significant digits than I need at this point. So we know that F net equals the total mass times the acceleration. But that total mass is M1 and M2. So I'm going to scooch down out of the way here. M1 and M2 is 12 plus 5. So that means 17, 12 plus 5, 17 kilograms times the acceleration is equal to 110.3625 newtons. So then I can divide to get the acceleration. 110.3625 newtons divide by 17 kilograms will give me an acceleration of positive 6.49 meters per second squared. And that positive means it's clockwise. So we have worked out the acceleration of the system. Now, part B of the question wants you to work out what's the tension. So for the tension, remember you're going to look at just one side of the pulley or the other. So you could look at these forces here or those forces there. And I'm going to choose the one without the friction on it, the one on the right. This one that's up and down, it seems to be a little bit simpler. So if I simplify it out, I'm just going to look at M2 here. M2 has gravity down and a tension upwards. And this is what we want to solve for. So we write a new F-net formula, and remember we can't go use the F-net from before. The reason we can't is because that F-net was for both masses, and when you're doing tension, you're doing only one mass. So we rewrite our formula. F-net is Fg2 and tension. F-net is just, need to scooch that a bit, it's just one mass, so it's M2 times A. Fg2 is M2 times G, and tension. So M2 times A is 12 kilograms times the 6.49 meters per second squared. And the M2G is 12 kilograms times 9.81 meters per second squared, and our tension. And we have to think about what our directions are. We know the acceleration was clockwise, so this was supposed to be positive. I know my Fg2 is downward. That was a clockwise as well, so this was supposed to be positive, so I don't have to go make anything negative. So now I can solve this for t. So we'll work out each of the numbers. Well, let's just take it over and subtract. So 12 times 6.49 minus 12 times 9.81 equals tension. So we took that to the other side. Okay, so when we work both of those out, it comes out to a negative 39.84 newtons as tension. That is counterclockwise, which is up the rope. Tension is always towards the pulley or up the rope for your tension direction. Okay, so complicated question. So how can we make this even more fun? Well, the way we could make this a touch more fun is by adding a third mass. I can almost hear you groaning as you see this question. So now we have three masses in play, M1, M2, and M3. M1 is 5 kilograms. M2 is 3 kilograms. And M3 is 9 kilograms. And of course, this wouldn't be a question if we didn't have friction. So mu equals 0.30. So I need to draw lots of forces. I've got gravity pulling down this way, Fg1. I've got gravity pulling on the rope over here. That's Fg3. I've got gravity pulling down on block 2, which is not pulling on the rope, but it's going to be a factor in friction. So I have Fg2 down, I have Fn up. Based on the numbers that I'm seeing, this 9 kilograms is going to beat out the 5 kilograms, so it's pretty clear that the whole system is going to move in this direction. So if the system's going to move in that direction, then the friction is going to oppose it and go backwards. And you have FF that way. So altogether, my free body diagram has lots of forces on it, but there's only a couple of them that are actually pulling on the rope. The ones that are pulling on the rope and are therefore going to be used for the acceleration, Fg1 is pulling on the rope, Fg2 is pulling on it, and friction. Those are the only three forces I'm going to use for my Fnet. So my Fnet formula is going to be Fg1, I labeled this as 2 by accident, but it's actually a 3. Fg3 over here, and FF. And I'm going to label those directions while I'm going here right now. Right, so I know Fg1 is going in the opposite direction to that green arrow. It's going downward. So that is a negative force. Fg3 this way is trying to make it go clockwise. So this is a positive one. And friction being backwards is making the pulley turn in a counterclockwise direction. So this is going to be a negative. So I've got the information to go work those numbers out. So I'm going to go try and calculate each one of these. Okay, so Fg1 was mass 1 times gravity. So that was 5 kilograms times 9.81 meters per second squared. So this is 4.905. We've seen this number a few times now, newtons. So Fg1, I'm going to put that in here as a negative 4.905 newtons. Fg3, I'll work that out over on this side. It's 9 kilograms times its 9.81 meters per second squared. And the 9 times 9.81, this one's 88.29 newtons. And it's a positive, so I'm going to put it in as 88.29 newtons. And friction is going to require a little bit of work. Friction, if I do it up here, I'm going to need to get F2G, which is mass 2, 3 kilograms, times gravity, 9.81. So 3 times 9.81 was 29.43 newtons. That means Fn is 29.43 newtons. They're equal and opposite. So then I can get FF. Because FF is mu times Fn. So 0.3 times the 29.43. And that comes out to 8.829. And this number, 8.829, goes in down here for friction. And I've recognized that that should be a negative because of its direction. So I'm going to put subtract 8.829 newtons. So that's how I will get my F net. So if we take our 88, subtract 8.829, and subtract 4.905, that gives me a positive number, 74.556 newtons. But that's what F net is. To get the acceleration, we know the F net is the total mass, all three masses times the acceleration. So you have a mass of 5, a mass of 3, and a mass of 9 that you're adding together. So that gives 17 kilograms times the acceleration gives 74.556 newtons. And so therefore, if we now divide, you take your 74.556 newtons, divide by the 17 kilograms, and we get ourselves a positive 1.79 meters per second squared. So there's my acceleration. It's clockwise. It's positive as we expected it to be as it moves through. We're not quite done the question because I'm pretty sure it asked us for what the tension in the rope is. So to get the tension in the rope, you can use any one of the three masses. So let's use this one right here. Let's use mass 1. So tension, we'll use mass 1. So using mass 1, we know we're going to write an F net formula. So F net equals, we have Fg1 and tension. You've really got only those two forces now balancing. We stayed away from the other messier areas. So F net is M1 times A. Fg1 is M1 times G. And your tension. Okay, so we've got to take M1, which is 5 kilograms, and the acceleration was 1.79 meters per second squared, equals, I need to move that down a little bit, equals a mass 1, which was 5 kilograms, times 9.81 meters per second squared, and then tension. So when I take 5 times 1.79, this gives 8.95 newtons. 5 times 9.81 is 49.05 newtons, and tension. But I've ignored my direction. We have to be careful here. So my F net was positive, because this was in the positive direction. That acceleration was positive. Fg1 is down. I'm going to move up. Fg1 is in this direction. So that is a counterclockwise direction. So this is a minus. So I have to make that a minus number. And now I can work out the tension in the rope. I can take this 49 to the other side now and get 8.95 plus 49.05 is tension. So 49.05, and that gives me 58 newtons as the tension in the rope. Okay, that same tension would have been determined if we went and looked at any of the other masses. You'd get the exact same tension, except on the other side it would be a negative 58, but it would still be the same size, same number of newtons. So that should be enough of a primer for you to go in and try a couple of different Fletcher trolley questions, and hopefully you can have some success.